Alright, welcome back to these videos, or I guess welcome to question 8 solution video. So we say applications of each new protocol adds a header of length h bits to a packet, and now we're asked the question, if a packet is undergoing applications of, if a packet is going applications of n protocols, what percentage, so what fraction of the resulting packet length is occupied by protocol headers? So, okay, that's relatively straightforward, right? So if we look at it, there's a couple ways to view this problem. We can view it as a sort of agnostic problem, like the header is never part of the packet, so I always consider the packet to not include the header. There's really two answers here, right? Depending on how you want to break it down. So I have a header here, and I have my message portion of the packet, which I'll call P, and I'll say that this whole thing makes up for L. Alright, so now this packet goes through another application of a header, and I have NH and then P, and so on, right? So I could say then that the percentage that is headers is NH over NH plus P. This would make sense, right, if at the very end, after n protocol applications, so say after n protocols, I'm not sure what the original packet was, right? So that's one way to look at the percentage, right? That's also another way of saying, like, it's the fraction that is headers over the total packet size, right? Another metric that's sometimes used is just to say NH over P. Now, these are not the same, right? This one here could be greater than 100, might be greater than 100% of the packet, and this one here will always be less than or equal to 100% of the packet, right? They're both correct ways to look at it. This is the ratio of actual packet information, or rather actual header applications to the packet information, and this is the header to the total packet size. Generally speaking, if you're looking for like the worst case scenario of the efficiency of your network, if I have a large computer network like a university, maybe it has to get many applications of headers to route within the university and then to enter the actual internet. So I might want to consider how much header I have to add over my packet when considering my bit error rate, or I could just look at the total. They're slightly different metrics, but both are, in my opinion, equally justifiable for a problem like this. So this is part one. Now for part two, you take whatever percentage that you calculated, and we say, what's the question? Let's see. After how many protocol applications is the length of the resulting packet at least triple the length of the original packet? Okay, the original packet is P, so we want triple the length, that's 3P, and we want it to be at least triple, that's greater than or equal to our packet length. So that packet length is NH plus P. So at what point is NH plus P greater than or equal to 3P? Yeah, let's see. So I mean, group the like terms. So I have 2P here because I subtracted 1P, and then that's NH. So I guess, yeah, there's nothing more to it than that, right? Now if I want to put that in terms of just n, right, I'll go back a step and I'll say 2P over H, right? So I guess this is your answer here. There's really nothing to it. It really doesn't hinge on your choice for part one. But again, this comes with a justification, right? This is the total packet, this is the original packet, right? This is the ratio of the original packet, that's the ratio of the total packet. If I'm asking the question, let's see, if a packet's undergoing applications and protocols, what percentage of the resulting packet is occupied by protocol headers. I would go with this because we're looking at the percentage that's occupied by headers. So that results in the total packet length. Now, if I'm looking from an efficiency standpoint of my network, I would like to look at this because I want to see the ratio, like how much more header to meaningful information in my packet from the perspective of an application layer user would there be. So for this specific wording of the question, stick to that side, stick to this ratio, and then part 2 is completely like different from this. Like the result of part 1 does not affect the result of part 2, so that's not even an issue. But with sufficient justification for why you would use that, there's still an opportunity to be correct. So that's all there is to question 8, and now we're on to the last question, which is question 9.